Hello everyone, welcome to my YouTube channel Chemistry Lovers. So today in this video I have shown you another reaction and it is based on organometallic chemistry. It is the oxidative addition reaction. Now first you need to know that what is this oxidative addition reaction. So first you can see that I have written this uh, configuration of a complex, right? M is a metal ion, any kind of metal ion you can use in this case. Any the obviously metal should be D block element, right? Like nickel, cobalt, iron, chromium, right? And L stands for ligand. N is the number of ligand associated with the metal ion. So this is a complex and it reacts with the heteroatomic molecule XY. And here this is the product. Now salient features, here are some important features about this reaction. First, in order to show this oxidative addition reaction, the oxidation number of the metal should be lesser, because here the metal center gets oxidized as well as the coordination number surrounding the metal center also increases by 2 units. So in this case the metal need to be oxidized, and for this reason the metal should have higher number of electron density, basically in d orbital, right? So thus I have written here, thus in order to show this type of reaction the oxidation number of metal should be lower, because since the metal center gets oxidized, thus the oxidation number of metal should be increases by 2 unit, right? Now the next step is the oxidation number and coordination number of the metal center increases by 2 units, as I have told you earlier. If you consider the oxidation number of metal is 0, then in the product the oxidation number of metal should be +2, right? As well as the coordination number you can consider 4. So the coordination number also increases by +2 unit, that is 6. So in this way this type of reaction take place. And here XY is any kind of molecule, whether it is polar, whether it is non-polar, any kind of molecule you can use in this case. If it is polar species, then trans product will be obtained as a measure, and if XY is non-polar, then syn product will be obtained as a measure product. Here this point I will explain you in later, right? Here you can see an example. This is, I have taken a complex where iridium central metal ion present and the 4 different types of ligand. One is Cl, one is CO, and the other 2 is triphenyl phosphine. Here the coordination number is 4 because 4 ligands present with the metal center directly. Here hydrogen, being a non-polar species, gets added with the metal center and the coordination number increases from 4 to 6. Alright, from 4 to 6. And the oxidation number of the metal center also increases from +1 to +3, because whether the hydrogen is a non-polar species, thus the cis product will be formed as a major product, because these 2 hydrogen are added from the same side with the metal center, hence this is a cis product, right? So in this way this reaction take place. Here another example, I have taken the same complex but the compound is mainly polar, because it is an alkyl halide. It is methyl chloride and it is basically a polar compound, because methyl have partial positive charge, Cl has partial negative charge, partial positive, partial negative. So this is a polar system and it also undergo oxidative addition with the given complex. Here coordination number is again 4 ligands present directly with the metal center, and the oxidation number for metal is +1. Oxidation number for metal center increases from +1 to +3, and coordination number as well as increases similarly from +4 to +6, because here methyl and chloride are 2 incoming groups gets added with the metal center, and this is a trans product. Why trans? Here you can see chloride and methyl are present at just opposite side with respect to each other. For this reason this is a trans product. Again another example you can see here. This is Wilkinson catalyst. You should know this compound. Wilkinson catalyst, rhodium, 3 triphenyl phosphine connected with it, and 1 Cl minus. HF is again a HF is basically polar compound, but here HF is also a polar compound. Thus trans addition take place. Coordination number increases from +4 to +6, and the oxidation number over the metal center increases from +1 to +3. The rhodium has +1 oxidation number because this triphenyl phosphine are neutral ligand, but Cl has a negative charge. Thus, there should be a positive charge present on the metal center rhodium. And here, F minus, Cl minus, H minus. There are 3 ligands bearing negative charge on it. So the metal center have +3 positive charge. So in this way, you can study this type of reaction, oxidative addition reaction. And this type of reactions are very useful in organometallic field and organometallic chemistry as well. So I hope you can understand this topic. If you have any doubt regarding this theory, then please ask me through the comment section. And if you like this video, then don't forget to hit the bell icon. Thank you.